This is Algebra 2, Lesson 5-9, Transforming Polynomial Functions. A power function is a function in the form of y equals a times x to the b, where a and b are non-zero real numbers. Like I can have y equals 3x to the fifth, or I can have y equals 1/2 x to the 1/4. It doesn't matter because real numbers, fractions are real numbers. The constant of proportionality says if y equals ax to the b, describe y as a power function of x, then y varies directly with x or is proportional to the b power of x, whatever that power happens to be. The constant a is the constant of proportionality. Now remember how we can obtain the graph of any quadratic function, the graph of the parent function y equals x squared, using one or more basic transformations? This is not always necessarily true of cubic functions. The graph of the function is a vertical stretch or compression by a factor of a horizontal shift of h units, and a vertical shift of k units to the graph of y equals f of x. So, if I want to transform y equals x to the third, what is an equation of the graph y equals x to the third under a vertical compression by the factor of 1/2, followed by a reflection across the x-axis, a horizontal translation of 3 units to the right, and then a vertical translation of 2 units up. Notice it says what is an equation, not the equation, which means there is more than one equation that would fit the transformations we specifically asked for here. We're going to write it in a specific form so that we only get one answer. However, if you were to multiply it all out, you could get a second answer, and then of course there could be other answers as well. We're going to stick with just the basics of the basics for this lesson, because I don't really want you to get too confused. So, if we're going to translate y equals x to the third, in order to compress it by a factor of 1/2, we're going to multiply 1/2 to y equals x to the third. So we're going to get y equals 1/2 x to the third. Step 2, to reflect it across the x-axis, we're going to multiply it by -1. So now we have y equals -1/2 x to the third. To translate it horizontally, remember it's always opposite what you think it should be when it goes inside those parentheses. So if we're going to move it to the right, 3 units, we're actually going to replace x with x minus 3. So now we have y equals -1/2 parentheses x minus 3 quantity cubed. The cube goes outside of the x minus 3. And last but not least, to translate it 2 units up vertically, we're going to now add to that y equals -1/2 parentheses x minus 3 quantity cubed plus 2. And that is an equation that follows the transformations we were specifically asked for this particular cube. Now, in general, y equals a parentheses x minus h quantity cubed plus k represents all of the cubic functions you can obtain by stretching, compressing, reflecting, or translating the cubic parent function y equals x cubed. Which means there's more than one for several of them in the cube. Now, if I want to find the zeros of a transformed cubic function, what are all the zeros of the function y equals 3 parentheses x minus 1 quantity cubed plus 6? If I want to find all the zeros, I'm just going to simply replace y with 0. And then I'm going to solve it for x. So 0 equals 3 parentheses x minus 1 quantity cubed plus 6. Now it's just simply an algebraic equation in which we need to solve for x. So the first thing I'm going to do is I'm going to subtract 6 from both sides. And now I have -6 equals 3 parentheses x minus 1 quantity cubed. Now I have to get rid of the 3 that we multiplied by the x minus 1, so I'll divide both sides by 3. And I have -2 equals x minus 1 quantity cubed. I don't want the cube, so to undo a cube, I take a cube root. And unlike square roots, I can take a cube root of a negative number, because remember, what's the cube root of -27? It's -3, because -3 times -3 times -3 equals -27. So I can leave that negative underneath there, and I do not need to put any i's in this particular equation. So I now have the cube root of -2 is equal to x minus 1. Right? To solve for x, I'm going to add 1 to both sides. And I have 1 plus the cube root of -2 is equal to x. And that's pretty much the answer to this particular equation here. And notice there's no plus or minus because this is not an even number group, so you don't have the plus or minus group. And we do that if you have square root of 4 to the 6. You could rewrite this, however. I have had people rewrite this to take care of this negative 2 and put it on the outside. They end up with F1 minus the QB of 2. Essentially, they're the same thing. This is pretty much all we're going to be doing with transforming polynomial functions at this point.